Hello, let's do checkpoint 6.7. Here we have the mass of an asteroid 1. Asteroid 1 is 750,000 kilograms. Mass of asteroid 2 is 130,000 kilograms. Assume asteroid 1 is sitting at the origin and asteroid 2 is at some point that is 15 along the x, -5 along the y, and +10 along the z. So this is asteroid 2. Let's assume that asteroid 2 was sitting there, and those 15, -5, 10 is measured in 10 to the 8th power kilometers. Asteroid 1 and asteroid 2. Okay, given the universal gravitational constant, g is equal to 6.7384 times 10 to the -11th. Find the gravitational force that vector asteroid 1 exerts on asteroid 2. So asteroid 1 pulls in gravity from all around, but then you have this asteroid 2, and you want to know the force that asteroid 1 is imparting on this is making it pull towards asteroid 1. So that's that vector that we're looking for. Okay, so we have to be careful with playing around with the units here. Let's start with our formula. Newton's formula says that the force is equal to the negative universal gravitational constant times the mass of the first and mass of the second, times the distance between the two asteroids divided by the magnitude of the distance cubed. Or not, r is not the distance, r is a vector that is going to be that placement of A2. So r, when we see this, we're going to assume that it's x, y, z, the vector x, y, z. And when we see r with no arrow on top, we're going to assume that that's the magnitude of the vector r, which is going to be the square root of x squared plus y squared plus z squared. So we can do those replacements there. All right, let's take a look at, rewrite our given constants. The gravitational force, or the gravitational constant, is 6.67384 times 10 to the -11th. And we'll tack on the units in a minute, but let's figure out the other stuff. M1 is 750,000 kilograms. M2 is 130,000 kilograms. Well, let's do the units. Let's do the unit analysis first and separately, so that we can just deal with the numbers when we get them down. So the gravitational constant is the cubic meters per kilogram per second squared. And then we have a couple of kilograms for the masses. Now let's figure out the units for the r. The r, we're going to be able to put in this value that's 15, but it's 10 to the 8th power, comma, -5 times 10 to the 8th power, comma, 10 times 10 to the 8th power, and this is in kilometers. So we're going to want generally we want the force in newtons, and the gravitational constant is actually given in meters and cubic meters. So we're going to want to change this into newtons, and to do that we're going to multiply everything by 10 to the 3rd, because we got from kilometers to meters. And so let's rewrite this. R is equal to, and let's factor out the 10 to the 8th times 10 to the 3rd. So that's, we'll keep that 15, -5, 10 vector. and then we have 10 to the 8th times 10 to the 3rd. We add the powers, 10 to the 11th, and now we are in meters. Okay, so that is the R, and now let's take a look at what R cubed is going to offer us. And so R cubed, if we follow the same logic and process here, it's going to be 15 times 10 to the 8th. This is in kilometers. Let's pretend we're going to put a km there. And then we're going to square it plus -5 times 10 to the 8th squared, kilometer squared, plus 10 times 10 to the 8th kilometers squared, and then we're raising this to the 3/2. So let's see, we got these are kilometers. We can make them into meters. So let's see how the kilometers fare out here. This is km squared, km squared, km squared. We'll factor out a km squared, so it'll cancel with this square, but it'll take it to the 3rd power. So this is km to the 3rd power. But let's see if we change that into meters. Then each of these powers will be to the 11th power, and it'll be in meters. So let's rewrite that as 15 times 10 to the 11th quantity squared plus -5 times 10 to the 11th quantity squared plus 10 times 10 to the 11th quantity squared to the 3/2. So what's going to happen with our units? We will have, well, first of all, let's take everything here will be in kilometers. Will be 10 to the 11th, 10 to the 11th, 10 to the 11th. We can factor that out. That's squared, undo the squares, and then we're going to take it to the 3rd power. So if we factor everything out, we will be left with 15 squared plus 5 squared plus 10 squared to the 3/2. So what are some of the other constants that came out? 10 to the 11th came out to the 2nd power, to the 1/2 power, to the 3rd power. So we have 10 times 10 to the 11th to the 3rd power. And these are going to be in, instead of kilometers now, this is going to be in meters cubed. All right, let us gather our units. So let's take a look at how our units are going to go. We're going to start with a G, which is going to be cubic meters per kilogram per second squared. We have a couple of kilograms that we're multiplying, and then we have meters unit on the numerator and a cubic meter unit in the denominator. Okay, after canceling a couple of kilograms, cubic meters, then we rearrange this to be m over s squared times kg, which is now our measurement in newtons. All right, so we got the units figured out, and they look like they all work together fairly well. And now let's figure out the actual numerical value for the force. So we have our negative sign, our G, 6.67384 times 10 to the 11th. We have 750,000, 130,000, and then we have this vector up on top. That's 15, -5, 10, and we're multiplying times 10 to the 11th for the numerator. and we're dividing by 15 squared plus 5 squared plus 10 squared. And what are we multiplying that? We're multiplying that by 10 to the 33rd power in the denominator, and the units are already all taken care of. Okay. So we just punch it into our calculator. Let's see if we can punch in all the constants. Actually, one way to do this might be to assign variables in your calculator. So let's just do one more simplification, and let's combine these two. So this is the 22nd power in the denominator, so let's cross that out, and let's multiply the denominator by 10 to the 22nd. Okay, and we'll assign variables. So let's start with the gravitational force. That's 6.67384, and we're multiplying it. This is in scientific notation, so I'll press the E, that's in scientific notation. This is negative 11th. I put 11th there. So let's put negative 11th, and let's store that into, let's choose the variable G for the gravitational force. Okay. So now we have just assigned this, including, no, we didn't include the negative sign, so that's G. Now I'm going to go ahead and multiply the 750,000. So that's 750, oops, let's do that on the calculator. 750,000, and then we'll multiply it times 130,000, and let's go ahead and store that into, let's call that one M. So alpha, and M is here. Okay, so now we have these two put together is M, and aside from the vector, this is the only thing we have left. Let's store this under, let's just use the variable A. So what is that? That is parentheses 15 squared plus 5 squared plus 10 squared. Close the parentheses, and we'll raise it to power 3/2. Oh, and let's not forget that we're going to multiply this times 10 to the 22nd. This is all in the denominator. And let's go ahead and store that into the variable A. Okay. So if we multiply those, we're going to get I'll lock the alpha, and let's say G times M. Oops, maybe I shouldn't have locked the alpha. So this G times M, and then we'll divide by A is what we call the denominator. Okay, so then our force looks like, I didn't put the negative sign, but let's just throw that negative sign in front now. This is going to be negative 9.93752,741 times 10 to the negative 26 power. And then we'll go ahead and multiply that by the vector 15 minus 5 and 10. So we can do it one by one, but I don't know, this is probably more calculator work than needed, but calculator has a matrix function. Let's access the matrix. Let's take number 1. We need to go to edit it. and we'll select A. So let's just press enter. And I want this to be a 1 by 3 matrix. And in the first slot, I'll have a 15. In the second slot, I'll have a -5. And in the third slot, I'll have a 10. So now I have my matrix. Let's go back, second function, and quit, back to the home. And we have this answer here. So I'm just going to put the negative and second function and the answer that we just got. And then we're going to multiply that by that matrix. So let's access the matrix again. Second function and matrix. And instead of edit, let's just select the names. Let's just select A or just enter. And so what I'm saying here is I'm throwing a negative sign, and my previous answer, which is the gravitational force, the gravitational constant times the two masses divided by that other thing. And then we're going to multiply it by A. Enter. And here are our values. So let's see if we can write it down. The first number will be a -1.490629112. It seems like it's a lot. There's an E coming there, so let's right arrow to figure out that this is going to be the 24th power. Comma. The next number is 4.96 8763707 times 10 to the -25th power, -25th, and then we have a -9.937527415 times 10 to the -25th power. Okay, that is the force that we have. It's in newtons. It's in cubic meters per, or just meters per second squared times kilograms. And so that's the force. Okay, that was a lot of computation, a lot of numerical values, and a lot of unit analysis and playing around with scientific notation. But I hope that helps, and good luck.